Hello, welcome to week 3 quiz tutorial. This week we're going to work with probability. Alright, let's jump in. The first question, you have 7 people checking their codes and the claim checks are lost. So what is the probability that all the people will get their own codes back? So we have 7 codes. Let's first determine the sample space. In how many different ways can you distribute these 7 codes to 7 people? Now let's assume the first person walks in and asks for their codes. You have 7 codes to randomly choose from and give one of those. The second person comes in, you have 6 codes left to choose from. Third person, 5 codes left, and so on. So until the last person comes in, you have one last code. So you're going to multiply all of these. So this equals product of these, which also can be calculated. This actually means 7 factorial, and 7 factorial is, there's a formula in Excel to calculate that, which is fact, short for factorial. 7, calculate 7 factorial, and that's the same thing as multiplying numbers 1 through 7. So 5,040 different ways you can distribute these 7 codes. So that's our sample space. Sample space. Now the desired outcome is giving all 7 codes to their exact rightful owners. So there's only one combination like that because each person has their own codes, and there's only one combination out of 5,040 that all 7 people get the right codes. So the desired outcome only happens in one way. So the probability then is just 1 divided by 5,040. Or we can say, just divide these, 1 over 1,040. Okay. So 1 divided by 5,040, that's 0.000198, which is right here. So that's number 1. Number 2, so we have computers generating random numbers, and then we add up those 2 values using the sample space provided below. So the sample space is provided here. So these are the randomly generated numbers. Find the probability that the sum is divisible by 4. So what you need to do is, first of all, count all these pairs, and that way you'll find out what is my sample space. So how many, so there's only 2 pairs in each row. How many rows do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 times 2, you have 36 numbers. You have 36 pairs. So the sample space is, 36. And then divisible by 4. So how many of the pairs give you a sum divisible by 4? So what you need to do is add each pair. 2 plus 2 is 4, and that is divisible by 4. So that's 1. 2 plus 3, that's not divisible by 4. 6, 7, 8, that works. So that's our second pair. 9, 5, 6, 7, 8 again. So that's number 3. 3, 9, 10, 6, 7, 8, that's number 4. Going quickly, 7 plus 5, 12, that's number 5. And then 6 plus 6, 12, that's number 6. 6 plus 2 works, number 7. 7 plus 5, number 8. And 5 plus 3, that also works, number 9. So there's 9 pairs out of this 36 that are divisible by 4. The sum is divisible by 4. So the probability is then 9 divided by 36, which is 0.2 25. It's actually asking it as a fraction, so you would just put 9 over 36, and if you simplify it, that's 1 over 4. So that's number 2. Number 3. An experiment consists of tossing 3 fair coins, except one of the coins, the 3 coins, has a head on both sides. Compute the probability of obtaining less than 2 tails. Less than 2 tails. Okay, so we have, let's clear this. So we have coin 1, coin 2, coin 3. Coin 3 is always heads, correct? First of all, when you have coin 3 is always heads because both sides are heads. Coin 1 can be heads or tails, right? Can be heads or tails. And coin 2 can be also heads or tails. Could be the other way, heads or tails. And I believe that is all. Yes. So coin 1 has 2 possibilities. Coin 2 has 2 possibilities. Coin 3 has 1 possibility. So 2 times 2 times 1, that makes 4, is our sample space. So what we have here is we have HHH, TTH, HTH, THH. So these are 4 possible outcomes. The question is probability of obtaining less than 2 tails. Less than 2 tails means you can have 1 tail or no tail. So this one is okay because it has 0 tails. This one has 2, that doesn't work. This one has 1 tail, so that one also works. And this one has 1 tail, that one also works. So other than this combination, these 3 would work, right? So we have 1, another 1, another 1. So 3 possibilities work out of 4. So that's why the probability of obtaining less than 2 tails is 3 over 4. Number 4. Lottery game. A single ball is drawn at random from a container that contains 25 identical balls numbered from 1 through 25. What is the probability that the number drawn is even or a multiple of 3? Okay, so even or multiple of 3. So what numbers are even? So it's 2, 4, 6, 2, 4, 6 until 25. So that's 2 through 24. And what numbers are multiples of 3? That's 3, 6, 9, and we stop at 25. So we have, as you see, we have 12 even numbers. So even is 12. Multiple of 3. Multiple of 3 is 8. And then the intersection, or both, because as you can tell, like 6 is both an even number and divisible by 3. So when I add these counts, I'm counting some of them twice, like 6 is being counted twice, right? 6 is being counted twice. And 12. So all of the even ones here are being counted twice. So what I need to do is either eliminate them or count them again and subtract from the sum. So 6, 12, 18, 24. So this 1, 2, 3, 4, see 6, 12, 18, and 24. So these 4 of them, so there are 4 numbers which are both even and divisible by 3. So those are being counted twice if I just simply add up 12 and 8. So I need to subtract their intersection. So desired is then 12 plus 8 minus 4, which is 16. And then the total total is obviously 25 because there are 25 balls. So the probability is then equals 16 divided by 25. So that's 0.64. Alright, number 5. In a lottery game, a single ball is drawn from a container. Okay, it's a similar problem. Find the probability that the number drawn is a multiple of 9 or a multiple of 4. So multiple of 9, so that's basically 9, 18, not 27 because that's exceeding 25. And then multiple of 4 would be 4, 8, I'm just going to write them all because that's not too many, 20, 24. So 4, 8, 12, 16, 20, 24, 9, 18. There's no intersection. See, 9 and 18, neither of them are a multiple of 4. So I can easily add them up. I don't have to worry about subtracting something, finding the intersection. So how many possible outcomes do I have? I have 8. So the desired here is 8, and the total is still 25. So 8 divided by 25, which is 0.32. So that's how we came up with that. Okay, number 6. Here's a statement, and we need to figure out if this is true or not. So if the odds for E, event E, equal the odds against E prime, so E prime or the complement of E, then the probability of E has to be 1 over 2. So first of all, this is really tricky. E and E prime are complements of one another. So if the odds for E actually is always equal to the odds against the complement of E, so you pick D. So this is, the probability doesn't have to be 1/2. Let me give you a counter example. Let's say, and let me just clear this. Let's say the probability of E is 30%, so 0.30. Then the probability of E prime would be 0.7, 70%. So that means odds for E and odds against E prime. Okay, so let's figure these out. Odds for E, so PE means E is happening in 3 different ways and not happening in 7 different ways. So yes and no. So yes is E is happening, no, E is not happening. So odds for E would be 3 over, so I'm going to put it this way so it doesn't turn into a date. Great, now it turns into a time. So 3, 7, oh, I hate that when that happens. So 3, I'm going to put it this way, 3 to 7. Odds against E prime. So E prime is 0.7. That means there's 7 ways E prime is happening and 3 ways it's not happening. So odds against E would be, see, it's not happening 3 different ways. So it would be again 3 to 7. See, it's not, the probability is not 1/2, but the odds for E and odds against E prime are always equal. So that's that. Number 7. A pair of dice are rolled 1,000 times. So in part A, we want to find the probability that the sum is less than 4 or greater than 9. So look at the chart. Less than 4 means it needs to be 2 or 3. So there's 10 plus 30, 40 different ways. And greater than 9 is 10, 11, 12. So 120 plus 80 is 200, plus 70, 270. And then there's 30, 300, 310. So it's 310 divided by 1,000, which makes 0.31. And the odds 4